Hi, I'm Catherine Sedgwick, and I'm presenting Group 23's project on terraforming. And I'll be presenting on behalf of Andre, Tiago, and Margarita. So the first time I personally ever heard about terraforming was on an episode of Doctor Who. And it was in this futuristic setting on another planet. And terraforming was, presented as this sort of way of transforming a planet to make it livable for humans through this big bubble of gases shown on the left there. And the Doctor kind of picks it up and he slams it on the ground and it breaks and all these gases are released into the air and it starts changing the atmosphere of the planet. So, knowing that this is a science fiction show, I was like, how accurate is this actually? Well, it turns out kind of accurate. The purpose is the same. It is done to transform a planet to support human life, that's true. And it does involve changing the atmosphere, the temperature, and the general ecosystem of a planet to make it livable. But it's not exactly done through this big ball of gases. Why is terraforming the thing that needs to be done? Well, as our planet continues to become less habitable due to overpopulation and pollution and things like that, it's necessary that we start looking for other places to live. But it's important that if we find another place, we have to actually be able to live there. Where could we possibly live? Mars is the #1 candidate, and that is because in its past it used to have an atmosphere a lot like Earth's. It does have nitrogen, carbon dioxide, and water, although the amounts are very different. For example, Earth has 78.1% nitrogen, whereas Mars has 2.7% nitrogen. And our amounts of carbon dioxide are very different, as well as, oxygen and argon. But the point is they're still there, and that's important as a place for us to look at living. The average surface temperature is also quite different. On Mars, it is negative 81 degrees Fahrenheit, and Earth is 58 degrees Fahrenheit. So Mars is really cold. But that's not something that stops us and is something that we could change through terraforming. It does have a rotation rate of 24 hours and 37 minutes, which is very close to Earth with 23 hours and 56 minutes, and it has an axial tilt of 24 degrees, which is, again, close to Earth with 23.5 degrees. It does, however, have a gravitational pull 1/3 of Earth's, which would make things very different. But again, not impossible. And even though it's about 50% farther from the sun, it's close enough to the sun in order to experience seasons, which is an important part of life on Earth. Another place we could possibly live would be the moon. Russians announced in May 2014 that they plan to build a manned moon base. The benefit of this is that it's closer than Mars. It's only a 3-day journey, and it does get twice the sunlight of Mars, so it's warmer. However, the moon is smaller and lifeless. It involves less work and investment to build an atmosphere, so that's a benefit. However, being much smaller than both Earth and Mars, that doesn't really solve our problem of overcrowding, which is one of the reasons we're looking for a new home in the first place. Other places we've looked at are Venus, but that's too close to the sun. It's 900 degrees Fahrenheit, and Europa, a Jupiter moon, and Titan, a Saturn moon, are both too far from the sun, so they're too cold. How would terraforming happen? Well, it would depend where we terraformed. So if we were to try to live on Mars, that would be done through global warming, which would actually be used to our benefit. That would involve factories on the surface, which would gradually release greenhouse gases into the air, and just like it does on Earth, it would heat the planet, but it would actually be a good thing for us because Mars is so cold, and it would melt the ice caps, allowing water to run over the surface of Mars. Plant life would also be grown to increase the amount of oxygen in the air so that we could breathe. Also, large orbital mirrors could reflect sunlight onto the surface and heat up the whole planet. Another possible way is propelling ammonia-based asteroids onto the surface, which would increase greenhouse gas levels. If we were to terraform the moon, that would involve bombarding the surface with water ice comets. And before they strike the surface, scientists would blow these apart, and then ice shards would glide around the moon's equator, giving it a crude atmosphere. And with more comets and pellets, the moon would begin to spin faster and would give a 160-hour-day cycle. You would, however, need around 100 comets to bring water and carbon dioxide, and these comets would have to be the size of Halley's Comet. And we still need nitrogen and genetically engineered plants to provide oxygen, so the comets don't really help with either of those things. So, if we were to terraform Mars, it would, in the beginning, look sort of like that on the upper left there, with the factories and all of that set up. And then hopefully eventually it would end up looking more like the other two images, with all the plant life and the water flowing and all of that. One other way that we've considered that is part of terraforming, but it's more like a shortcut of terraforming, is shell worlds. So that would involve encasing a planet in an artificial shell, and it would be made of dirt and steel and Kevlar fiber. And that would allow us to maintain the atmosphere and create an Earth-like environment all within this little bubble of sorts. The cool thing about this is we would have artificial light, so we would be able to control the heating and the cooling and how long our days are. We would also be able to choose the composition, the pressure, and the temperature of this world within this bubble. And the bubble itself would provide UV and radiation protection. So really, this one is all about control. So on the upper left there is what the shell would look like with the planet inside of it. On the bottom left is the factories and the industry and spaceports on the outside there in the vacuum of space. The artificial lights on the inside, and we would have a sort of hanging city or a floating city hanging off the top of the planet there, and so we could live in those little hanging cities, which looks really cool and futuristic, honestly. And also with the low gravity, we would possibly be able to fly, which would be really cool, and is one benefit of possibly doing this through shell worlds. So in conclusion, is this possible? Yes, and it is why we are studying this method of, finding a place for us to call home. So it's not quite science fiction. The bubble of gases and that we could just smash on the ground, that is, but it is a legitimate form of study and something that we are looking into. However, it is going to take a lot of time, whether we do it through greenhouse gases and plants, or if we figure out how to do the shell worlds. It's all going to take a lot of time, so it's really important that we take care of the Earth as it is right now before we start looking at other places. These are our references, and thank you very much.